Good morning. Welcome to the concluding lecture of Sustainability and Green Manufacturing Systems. And today what we will do is we will try to converge upon the sustainability and green manufacturing and the importance of sustainability as a course in engineering. I apologize for my throat because my voice is not very good today. You'll have to bear with me in this regard. So if you look at the course content, we started with the green factory quantification. Then we looked at the overview, we looked at the topics like sustainability, and we also looked at stuff like productivity. Then we looked at things like unit manufacturing processes, unit manufacturing process or processes. Then we looked at also things like the simulations, then model building, etc. We looked at optimization. Then we looked at various aspects of energy, then cutting fluid, work environment, etc. So and then how we talked about building a green factory. So we have covered many topics as part of these, and in that whole process, what I'm more interested in discussing today is that how does a course like this is relevant to the engineering and as well as the entrepreneurship. So I would like to introduce two concepts. Like let's first talk about science versus engineering here. Okay. So a lot of the time, what is science? So the simplest way to look at it, there are so many formal definitions, but I usually look at it this way. It is like a study of natural phenomena as much as possible, or understanding. So understanding phenomena, natural or can be some specific phenomena, that's what you can think about a science. Whereas engineering is applied understanding. So an example is, if you study the concept of friction that you study in physics, okay, that you can think about it, and then modeling frictional force is equal to mu r, whatever you want to call it, that you can call it a science. Whereas designing a system to minimize friction, that would be engineering. So engineering is an applied side of science, as if you think about it. So in that regard, sustainability, rather than studying the theory, the current need of the hour in the world is having the sustainability principles applied in real life. So that's why the engineering is one of the best ways where you can actually have sustainability implemented. Keeping this in mind, let us look into the next aspects. So one of the things that we studied about the green factory quantification is that we looked at how can we quantify the overall variable energy savings, okay, and how do we evaluate that. And the equation that was given, eta overall, which is the efficiency, this eta overall is the percentage savings in overall energy. Okay, so overall energy is the overall variable energy that we talk about. Okay, so this is where we were looking at, if you remember, there were two type of coolant that was used. One was the flood coolant method, where you have the workpiece completely flooded with the coolant, and as well as the next one is the MQL, which is the minimum quantity where you are actually atomizing the coolant and spraying it in the workpiece. On all the conventional machines, there are different processes that were discussed, which was include grinding, milling, etc. Milling, EDM, these kind of many processes you might have been familiar in the course. So the overall efficiency, the percentage savings in overall energy, eta overall is the savings. Okay, the percentage savings is the energy EOF. It is the overall energy, average overall energy using the flood setup. So EOF is the average overall energy. So if you have this, you can think about it as sigma overall energy divided by some number, which will give you the average overall energy. The average overall energy for the machine using the flood. So the coolant is flood, okay, and EOG. OG is the average overall energy of machining using MQL, okay, the MQL setup. MQL green setup is the MQL vegetable oil. We can think about it as MQL. You remember there were two aspects. MQL setup, one has the MQL with the mineral oil and MQL with the canola oil, vegetable oil. Both of these cases in MQL, so if you compare to flood, MQL is way much less, it uses way much less cutting fluid than flood mechanism. And among this, with the MQL mineral and MQL vegetable oil, the vegetable is more sustainable. Oil is more sustainable. Okay. So the overall energy that is spent on the MQL and the overall energy that is spent on the flood, you find the difference, divide that by the overall energy in the flood mechanism multiplied by 100. Okay. So you can see that by doing this study, we can identify that the reported energy savings is about 20% in line 1 and 40% in line 2. So in line 1 you had 3 conventional processes, I believe, and line 2 had EDM. So wire cut EDM, mu EDG is what you are using here, and you have a grind, a mill, and a drill and inspection. That was one line. Another one was WEDG and inspection. So in this was the line 1. Okay, we remember we talked about flow shop, and this is a flow line 1, and this was a flow line 2. So this line reported 20% savings, and this reported 40% savings. If we followed this equation, this overall energy, average overall energy method, this is what we are identified. So remember that this equation helps you to estimate overall energy by comparing the machining of flood versus the proposed machining of MQL for the conventional machines. So we are comparing the average overall energy. Again, I would like to repeat, average overall energy compared with the typical flood setup against the average overall energy for the MQL setup, and from there the difference is divided by the overall energy for the flood setup multiplied by 100. It will give you the percentage savings in overall energy. So even if you are saving the energy, it says 20% savings and 40% savings. When if you take the lower value of this, if it's only 20% savings, that is a significant amount, because 20% of savings in energy is important in any manufacturing system, because one of the major costs is the energy savings in itself. The second part is the green. Again, we talked about green quantification. There's another method, because you just don't have to look at one option, you can look at multiple options, and we will see why it is. There was another equation that was used. The savings, another method is to quantify the savings in variable energy. The other case was average overall energy. Here we are talking about the variable energy. Okay. So eta overall is the percentage savings in the energy, but instead of overall I would say variable energy. Sorry, overall savings, the savings in the variable energy. So it is given by sigma summation of Pi times eta I. So Pi is the percentage of processing time for machine I. So how much time the machine spends on processing the part. Okay. So that is one part. So if you think about it in a graph, this is the time, and this is the, if you think about as busy, let's take this as 0 and this is 1. 1 means the machine is working, 0 means the machine is not working. So for some time the machine will not do anything. At one point of time a workpiece will come in, it will immediately become 1 and process it for some time period, then it will become 0, then it will wait for a part, then it will come, it will process for some time. So it's something like this. So if you take the total time like this, and so then these times is when the machine is busy. So that part, so this will be, let's take this as T1 plus T2 for the time being. Then T1 plus T2 will give you the T2 by total time will give you the percentage processing time for the machine I, okay, particular machine, whatever the machine is, okay. Eta I is the percentage savings in energy for each machine. So if you know how much is the percentage saving for each machine going on, then so if you divide that by the pi is the processing time. If you do that, then what you get is the overall savings in the variable energy. So you are only considering the times in which the machine is working. The machine is idle, we are not considering the time. So what we are saying is that if you look at the energy, the machine might be using an energy in this fashion. This is energy. So default it will be consuming an energy like this. But whenever it is busy, the energy consumption will probably go up something like this, do something like this, will come down. So some stuff like this you will see. So the energy consumption is more, there's a baseline consumption of energy, and this additional consumption you can think about it as variable, okay, variable energy. So what we are trying to talk about here is how much is the variable energy, because that's energy that will be used in making the part. So once you know the percentage savings in energy for that particular machine, then we know I is the unit manufacturing process, milling, drilling, grinding, and mu WEG. We mentioned about the 4 processes. So the idea, as I said earlier, the rationale behind this method is variable energy is consumed only during processing times. So whenever this is the processing or processing of part J, okay, or job J, you want to call this part J or job J, it doesn't matter, okay. So whenever you are processing a particular job, then is only when then the machine will consume additional energy, and that variable energy, so the variable energy is energy used to process a given job J, okay. So only when you have a job, that is when the machine will use the energy, additional energy. And so the advantage is that if you ignore this type of energy, which is the, you know, when machine is on, this energy will be consumed. So ideally speaking, most of the factories, the machines will stay on. So hence this kind of consumption will continue no matter what throughout the time period. So if you only look at the variable energy part of it, then the overall reported energy savings are close to 30% for a green factory. So they are saying that if you look at only the variable energy, 30% savings if only variable energy is used, okay. So 30% savings were reported when you are looking at the variable energy, and in the case of the other one, it will be 20% for the conventional machines and 40% for the mu WEG. So this is also another option for looking at the green factory quantification. Then the third factor that we want to also discuss here is, you know, the savings on cutting fluids. So we talked about, one was the energy savings, another one was the savings on cutting fluids. So this is less energy implies more sustainability. How? The more sustainability will come because less energy implies lesser demand on fossil fuels. Okay. So if you are lesser demand on fossil fuels, then lesser pollution. Okay. Then like that. And if you are having lesser demand on fossil fuel, another option is you can think about lesser energy will result in more chance of success for renewable energy like solar. So, you might not be able to produce that large quantity of energy from the renewable energy sources, but if the energy requirement in itself is less, then the chance of success for renewable energy cases are also pretty high. So, this is one route of the energy. The cutting fluids, the advantage is that most cutting fluids are non-biodegradable. Okay. So, if they are non-biodegradable, then what happens? Disposal becomes an ecological problem. So, two strategies we can think about. One option is minimize or the reduce strategy, reduce cutting fluid usage. Okay, that's one option. Another is substitute with biodegradable fluid. What we used here was we used a combined strategy of reducing plus replacing with biodegradable fluid. So, mineral fluid, mineral oil based systems, sulfides, chlorides, etc., chlorides based systems, etc., they were changed to vegetable oil, biodegradable canola like oil, without compromising the product quality, without compromising product quality. Surface finish was used. I am pretty sure you remember all those aspects of the course. So, when this strategy was used, it is important to identify how much of the cutting fluid savings was done. And the savings are compared against the flood usage, because typical usage is the flood and the MQL setup. So, the ETA cutting fluid, that's the overall percentage savings in cutting fluid. So, this is the savings in cutting fluid. Okay. What was that? It is the C flood. This is the consumption of cutting fluid using the flood setup. If you use the flood setup, how much it is? You are pouring cutting fluid and the workpiece is submerged. So, the flood is, you remember, it is the submerged workpiece. Okay, or we are using it as much as we can. And the MQL is the consumption of the cutting fluid in the MQL setup. This is the second term. So, the difference between this, typically the C flood is way larger than C MQL, or consumption of MQL is much lower. And then you divide that by flood and take the percentage of this, and you can see that the cutting fluid savings were close to 90% when evaluated for 8-hour shift, 22 working days in a month. Okay. So, if you assume that there are about 22 working days in a 30-day month, then there is the savings is about 90%. 90% savings is a huge savings, especially if you are able to reduce the cutting fluid usage. Even if you don't come up with a vegetable oil setup, then MQL mechanism, this gives you the strategy of reduce. Okay. And then when you replace this MQL, the mineral oil, the chloride sulfide based system with a vegetable oil, then what you have done is you have already reduced it, plus you are substituted it with a better material. Okay. So, this is how you come up with sustainable strategies for things. Remember that the MQL flow rate was 20 milliliters per hour. You are only using 20 milliliters per hour, whereas the flood was using 50 liters of fluid in a month. So, if you have 8-hour shift, okay, this is 8 hours. Okay. So, in a day it is 20 milliliters per hour. So, 20 milliliters times 8, that is equal to 160 ml for a shift is what we are using instead of 50 liters in a month. When if you take 22 days, you can see how many less quantity of your cutting fluid we were actually end up using. So, so we are actually, it's a good demonstration of how the reduce and substitute strategy can be implemented to ensure sustainability in the system. So, we have already seen the energy savings, now we also seen the cutting fluid savings, and you can see that the cutting fluid savings are of much larger impact than the other savings. So, with all these kind of things said together, we now get into this discussion of sustainability in education. Okay, why do we need to understand or learn the concept of sustainability as part of our curriculum? Okay, and I mentioned earlier the science versus engineering concept. So, why do we need to study sustainability in engineering curriculum? Why engineering? And the relevance, what is its relevance? Why is it relevant? Why is it means sustainability relevant to engineering? What is the important aspect of it? Okay. So, few things. The few important points that comes out of our mind is engineering to a large extent involves design of systems. Okay. Various systems to accomplish things. It could be manufacturing system, weapon system, it could be a transportation system. So, engineers design all these systems, they manufacture them, they build them, they operationalize them. All these things are part of the engineering system. So, then when they are working on designing of the systems, then obviously instead of just designing a system, engineer should have a mindset to design sustainable systems. Okay. So, the system, we instead of just designing the system, we should be designing sustainable systems. So, what is a sustainable system? A system is considered as sustainable. Okay, you can call it as sustainable. This is kind of a rough definition when it is resilient. So, this is the key term, resilient. What do you mean by resilient? It is that the system can accept externally imposed stress or intervention and return to its characteristics, levels or patterns of functioning. So, if we had a sustainable system, for example, if we had a MQL based system, manufacturing system. So, we are looking at MQL based cutting fluids. So, then your demand for non-biodegradable fluids significantly reduced. So, when you have the significant reduction in your non-biodegradable fluid, then if there is a sudden change in the market and the cutting fluids are not available, you can always get away with the little amount of cutting fluid that is left out with you, because you do not require it in large quantities. So, when you require small quantities, it is easy for you to store even some of those. Plus, on the top of it, since you are able to demonstrate that vegetable oil, specifically canola oil is capable of replacing non-biodegradable system oils. So, this was used as an emulsion. Okay. So, at some point of time, this non-biodegradable cutting fluids are not available, then obviously you can replace it with a vegetable oil emulsion. Hence, what you are saying that even if there is an externally imposed stress or some intervention from that's outside is coming in, then the system should be capable of absorbing it and continue to function. So, that is the advantage of having a sustainable system. So, engineers should be trained to design such type of systems. That is one important aspect of the need of sustainability in engineering education. Also, second part is we should also move away from traditional sequential optimization strategies. So, earlier what we used to do was we used to have this typical model of input and a black box. So, where we call it as a transformation process and output. So, this thought process to a large extent also gave rise to what we call as a sequential optimization. So, you either optimize the output then you optimize the transformation process, then you optimize the input, kind of a thing. But now that we have seen that we also look at not just the same way, we also look at the system like this, where you have multiple inputs that are going into the system, and there are multiple outputs that are coming out of the system. There are multiple things that are coming in, there are multiple stimuli, energy and other things are going in. So instead of just doing a linear sequential optimization, we are looking at a scenario where a holistic approach is used. Okay, so holistic or systemic approach is necessary. Okay, so that is the so the sustainability, if you are trying to impart sustainability as part of the engineering education, then instead of the traditional sequential optimization approach, people should be given a holistic systematic approach in optimization should be done, where they should be looking at the system as a whole. Okay, which implies it requires a non-linear holistic approach for solving the problem. So this approach should be bought into the students. Okay, so this requires something new that's called as a systems thinking. You need to think about the system as a whole, not a component of the system. Because the reason is, when you try to optimize the whole system, it is usually inconsistent with the optimization of individual subsystem. So in olden days, what you used to do was, let's break down into small parts and let's only focus on a small part and optimize. Maybe the optimization of that small part or the individual subsystem might not be the best optimal solution for the whole system. So which creates a concept of trade-offs. So you need to decide, there are a lot of pluses, so multiple positives, multiple negatives. These are always available in any optimization. There are positives and negatives. So then choose appropriately. So how will you choose appropriately? That is the tricky part. That is where you require the systems thinking. Because we found out that one option is, if you use the flood mechanism of coolant, then we found out that the noise is low. Okay, dry, the noise was high. So then the MQL is kind of a noise in between. So if you think about it as a graph, you can think about this way. You have a flood, dry, MQL. So if you have the noise level here, so flood will be something like this, dry will be something like this, MQL will be something like this. So obviously flood will reduce the noise level, dry will create a large amount of noise, MQL is somewhere in the middle. So are you willing to do this MQL as a trade-off? The trade-off here is, you will end up reducing a large amount of non-biodegradable cutting fluid. Are you willing to take that positive and have a little bit higher noise than the flood mechanism? Are you willing to do that trade-off? So such trade-offs, the systemic trade-offs as a whole, you are not really, if you just only focus on noise as an example, then you will obviously choose this. So this kind of a views are called as myopic views. And the large view, the whole system, which is called as a holistic view, where you look at other aspects as well, is when you will end up doing trade-offs. And then you need, but the biggest thing about trade-offs is, you need to recognize a priori and you need to address them. So you need to look at different alternatives. So in another way to look at it is alternative analysis. So what else? That kind of a question also the engineers are to be taught and made them to understand. Now we will get into the specifically sustainability in engineering. What are the key points that the engineering curriculum should do to instill sustainable engineering practices or instill the value system into the students? So obviously these 6 points need to be thought through in this case. The point number 1, the first important point is economic. Okay, the system that is engineered should be affordable. In the case of the if I look at the MQL system, okay, the system that is engineered is affordable because you are reducing the cutting fluid by 90%. So your savings of cutting fluid savings, cutting fluid cost savings is huge. Okay, so any reduction in cost. The system should be affordable means you cannot expect it to be more. Like initially when the electric cars were bought in, they were not very affordable because there was not sufficient charging points, and per charge it used to run to maybe maximum of 100 kilometers. So they were not suitable for long distance travel. But now that the Tesla models have come up, where there are charging stations are also available on the road, so now people started moving to electric cars because they are viable options. So now what has happened is the system has become affordable, okay, or the cost of ownership should be low. This is an important consideration when you design any sustainable system. It has to be economic. Number two, it has to be environmental. Environmental means it should not degrade the environment. By implementing the system, the environment should not be degraded. Classic example here again I will use it is the cutting fluid savings plus. So this is where we were like, okay, we can now say that we can get the same amount of surface finish by using the MQL system. Now can we change the non-biodegradable to biodegradable? So this is where you are trying to minimize the impact of the system, so that you are now trying to degrade the environment. So this is also the second part of the second most important point that people should think. Third, it should be functional. Okay, it means functional implies the system should meet the user's need, the customer needs. Whatever the needs of the customer should be satisfied. Okay. So this is the important part of it. So it should have functionality, health and safety in its overall life cycle. So the system should also be functional. It should be economic, it should be environmental, and it should also meet all the needs of the users. Okay. So like for example, when Tesla was designing the cars initially, the biggest problem with the electric cars was that they were not fast enough. But now many of the electric cars are fast and have very good rapid acceleration and has all the creature comforts that is available as that of a normal fossil fuel based car. So the user needs, unless you don't meet the user needs, then you will be then the system that is designed will not be accepted by the user. So that should also be the third point consideration of that. Fourth part is that it's a physical aspect. So that means the system should be physically capable to endure the forces associated with its use, and as well as accidents, willful and nature hazards over its intended service life. So that means it should withstand the forces associated with its use, and it should also be capable of dealing with all sort of accidents or unexpected scenarios it should come into the picture. So for example is that again Tesla car, electric car, the biggest thing is that it has safety ratings. Earlier days, a collision of an electric car was a dangerous thing because of the batteries that were used in it, and the acids that were involved were creating much more bigger of an issue. But now with the much more better advent of the batteries and other things, the advantage is that the car is now capable of providing the same amount of safety and security as that of a conventional automobile. So physically the car is non-distinguishable as against that of a gasoline based or gasoline or diesel based automobile. So physical aspect of the system is also an important aspect. Then comes the political aspect, the fifth point. Okay, it should be inconsistent. The system should be inconsistent with the public policies. So if we say Bharat BS4 norms, or these are the emission norms. Okay. So whatever you do, I am just giving it as an example. Whatever you do, the public policies, the environmental policies that are related to the system should be satisfied. One of the major things that we hear about, one another example in India is the Pollution Control Board. When people talk about a lot of the industries in India, people say that there are many industries who don't adhere to the environmental norms or the pollution norms. So why? Because sometimes the cost of making the conventional system to fit the public policies is quite expensive. So they conventionally bypass it, conveniently bypass it. But if the system has been designed properly to begin with, then adhering to this public policies would not have been an issue. So, the engineers who are going through the education in the normal engineering education system should be given this outlook that whatever the system that they are designing, that system should also fit the public policies, that it should also ensure that the law of the land is also followed in this case. And the last part is the social aspect. The system continues to be acceptable by those affected by its existence. That means the people who are adversely impacted by its existence should also be able to, accept the system. An example is Tata Nano in Singur. I hope you might have read about this case. It was in West Bengal, where Tata had to change the factory from Singur to Gujarat. Okay. And the issue was that the people who were affected by that, the farmers of Singur, were not willing to. Well, there are political reasons also behind that. That's a different story. But the people, it should be acceptable to the people affected by the existence of the system. That also is an important aspect. Okay. So, if this is important that these 6 aspects are also taught or made clear to the engineering students at the time of learning different policies and philosophies and systems, because if this is embedded in the DNA at the time of education, the pedagogy is right in imparting this value into them, then obviously the systems that they design will also have that value of sustainability as time progresses. The last concept is we talk about sustainability in entrepreneurship. One of the important aspects of education is converting knowledge to wealth, and entrepreneurship precisely does that. It converts the knowledge to wealth. So, the latest topic that comes out is the sustainopreneurship. Okay. So, it is sustainability, and so it's sustainability plus entrepreneurship gives you this term sustainopreneurship. It is basically called as business with a cause. That's what people usually call it. Okay. The idea is that you have whatever the business you do, okay, whatever be the business, the concept of sustainability is prime importance. Its importance, okay, prime important. So, that kind of a thing where you are doing a business with cause, that is the new accepted not policy, newly accepted norm in entrepreneurship. So, the sustainopreneurship looks at something called as balanced growth instead of growth at all cost. So, this growth at all costs is the classic example is China, and you have seen what is going on in China, the pollution, the air quality, etc., and how China is trying to sell, fresh air, oxygen and those kind of things. People are buying air now like you are buying water. Similarly, but on the other hand, if you look at the balanced growth, then the balanced growth is an example of where you are trying to minimize the environmental impact. A classical example of this is the philosophy that Germany does. Germany is a country that somebody at one point of time is saying that it's about 20 lakh crores in surplus is how much they have. Okay. So, but what they do is, even though they have no deficit, they have surplus budget, but still even they are growing at a surplus budget and they have a lot of money and other things, still they are very focused on balanced growth, that is growth without hurting the environment. Whereas the other hands, growth at all costs, that is what China does. So, this is an example of how you can achieve growth, better growth, without harming the environment. So, sustainability entrepreneurship. So, concluding, I will say that sustainability entrepreneurship builds on the basics of entrepreneurship, converting knowledge to wealth, and extends it to encompass addressing ecological and social concerns. So, you are interested in making money, you are interested in growing, but you extend the concept of growth to encompass, to bring together the ecological issues and as well as social concerns through the creation of new enterprise and innovation of existing enterprises. So, either you create a new enterprise where then you embrace the ecological and social aspects as well, social plus growth, okay, or innovate on existing entrepreneurship, existing enterprises. So, in this course we have seen how can we convert an existing system into a sustainable system as well, or a green factory. So, that is an important aspect as well. Okay. So, you do creation of a new enterprise that encompasses the ecological and social concerns, or innovate new things in the existing enterprises so that it also is embracing the ecological and social concerns. So, then that is where we call as a sustainoprenneurship comes into the picture. And concluding, I would like to bring few points across to you, these four points, and I think that is also quite important that you realize these 4 points and maybe strive towards this as engineers of future. So, the first point is business leaders, the people who are associated with the business, who are running the businesses. So, the business leaders, they are looking at social issues as a new market, okay, and successful social minded enterprises as potential investments. So, people are looking at social, where ecological and social issues, whatever the businesses that are capable of addressing it as the new market systems. Like classic example of it, one company is called Tesla, that many people talk about, and many people talk about how it is worth in investing in Tesla because of their futuristic technologies, how they are doing sustainable business development, that kind of an aspects. Now many companies are getting into this as well. Pharmaceutical companies like J&J are all getting into this business of sustainable development or sustainable growth as an important aspect. Okay. So, that is one part. So, the one part of the equation, the business leaders are thinking about it. The second part is the consumers have begun looking for safe, reliable, high valued products, and they are willing to pay a premium. A classic example is the electric cars now. Earlier people were not willing to pay electric or hybrid cars. Okay. People were not willing to pay a premium for such products because they were like, what is the big deal? But now, given the awareness has increased and other stuff, people are willing to pay a premium for such type of products that are safe, reliable and ecologically friendly, high value, or the value associated with that products to the human being is very high because the minimal impact it does to the society, to the ecology and as well as the society. The third aspect is employees are now willing to leave comfortable lifestyles and jobs for the prospect of building a new model for change. So, the employees are also being now, okay, we would be rather, so when surveys were conducted, how many of them were their dream company to work for? People earlier used to say about Google and those kind of things, but one of the company that has shown up recently in the dream company is Tesla, an example. So, people are like, we are willing to take a pay cut to go and work for Tesla because they are coming up with technologies that are going to be futuristic and save the environment and save the world. So, employees are also now being willing to do that. And last but not the least, the government is also investing the significant time and energy to help solution providers incubate and scale up their business models. So, government is also supporting such kind of endeavors. So, these 4 stakeholders, the leaders, the business leaders, the consumers, the employees and the government, all promoting together sustainable endeavors, sustainable business practices, is this gives the right what you call as rather than saying it as an ecology, we would call it as a right setup or appropriate setup or ecosystem. It provides a setup or an ecosystem that allows the such kind of ideas to prosper and become successful in the industry. So, with that, I think we come to the conclusion of this course. Hope you guys have enjoyed at least the understanding the importance of sustainability and how can you bring sustainability into a existing system where you can realize things like saving of energy, minimizing cutting fluids, reducing the noise, making the worker environment safe, minimizing the emissions, pollutions, etc. like that. It's a vast area, by the way, and this is just a peek into the small aspect of sustainability and also a kind of an understanding of how we can realize sustainable practices for business. With that, I wish you all the best in the coming courses and as well as hope that you enjoyed the course, and thank you very much.